Now we'll see a different type of assignment problem, which we call that as traveling salesman problem. This is also a similar problem to restriction on assignment, but these restrictions are more, and we'll see how it will be. Usually the problem is presented in such a way that there is a salesman who has to travel to various places, but the restriction on that is, say if he has to go to places, 5 places, A, B, C, D, E, as which is shown in the problem, and in that case he can move in any order. He may start anywhere, but he can move to other places without coming back. That means if he comes back, it is like duplication of work. That means he will come back again, he will go to another place, and from there again coming back, it will be a costly affair. Here our purpose is to minimize the distance traveled while covering all the locations. So in this problem we see we have this is the problem where we have A to E. That means we have places A, B, C, D, E, and he has to start somewhere and visit all the places in any order he wishes. Only restriction is he cannot come back, so that he will minimize the distance. He will go from one place to other, from there he will go to different other place, from there again he will go, finally he will come back, and without repeating or without coming back to any location he has already visited. So here from A to different destinations, these distances are given in miles. Let us assume the distance is in miles. From A to A we see this hyphen. Hyphen is nothing but there is no distance. From A to A, even if he travels, he is in the same place, there is no distance. B to A we have 27 miles, but B to B it is no. So B to C we have 21 miles, B to D 18 miles, B to E 42 miles. Similarly, C to A you will find 33, C to B 26, C to C nil, C to D 19, C to E 28 miles. D to A it is 17, and D to B is 29, D to C 31, and D to D nil as we have, and D to E 18. Similarly for E, E to A 24 miles, E to B 27 miles, E to C 34 miles, E to D 22 miles, E to E nil, which we are showing. When we have traveled to the same location, we are putting this as hyphen because he will be in the same place, there is no traveling required. And there is one assumption in this problem that A to B distance is not the same distance from B to A. If you see in the problem, A to B we will find 30 miles, but from B to A it is 27 miles. Let us assume it is similar to one way. That means you can only take that route which will be 30 miles if you have to travel from A to B. That means we are supposed to go in that particular route which will be around 30 miles. Whereas when we have to come back from B to A, we may be taking a route whose distance is 27 miles. That is the reason we don't find the same distances. Even you will see A to C it is 17 miles, but whereas C to A it is 33 miles. Or A to D is 20 miles, whereas D to A is 17 miles. that restriction or that constraint we have to keep in mind, and we have to solve this problem. In the next step, what we are going to do is, from A to A, we assume the distance to be infinity and we will write, then based on that we will conduct row operation. So for the same table we will find out the row operation, and then we will proceed with allocating the units after column operation. That means after row operation we are going to make column operation, and then we are going to see. Now we will start row operation, which is the first step in solving this problem. As we have earlier discussed, we are going to put infinity in place of the A to A distance, or B to B, C to C, likewise. So we will start with this A to A infinity. Then we will identify that the lowest element is 17, and in the row A, 30 minus 17 is 13, 17 minus 17 is 0, 20 minus 17 is 3, 25 minus 17 is 8. Then in the second row, we have the lowest element is 18, 27 minus 18, 9, and here infinity, because it is B to B. 21 minus 18 is 3, 18 minus 18 is 0, 42 minus 18 is 24. Then in the third row, we have the least element is 19, 33 minus 19 is 14, then 26 minus 19 is 7, then it is infinity, 19 minus 19 is 0, and then 28 minus 19 is 9. Then in the fourth row, the least element is 17, so 17 minus 17 is 0, 29 minus 17 is 12, and 31 minus 17 is 14. Then it is D to D, infinity, and 18 minus 17 is 1. And in the E, or fifth row, we find that lowest element is 22. So 24 minus 22 is 2, 27 minus 22 is 5, 34 minus 22 is 12, so 22 minus 22 is 0, and last E to E is infinity. After this we are going to conduct the column operation, and as we know, in column operation, if there is if any element of the column is 0, we will write down the same as it is, because anything minus 0 remains to be the same kind.